Hello, my name is Kirill, and I work on tooling at Lido. And today I want to talk about the tooling for node operators version 2. First, I will tell about the scope of changes, then I will mention our schedule, and then I will go through some technical stuff. And it's okay if you don't get it at first. It took quite a long time for me to understand all the technical details. And of course, feel free to ask questions at the end. First scope is withdrawals. And as you know, it's the big thing for Ethereum, and we should be prepared. The second scope is a staking router, and it's basically the load balancer for a stake. If you want to know more about staking router, you can watch previous node operators call recording. So withdrawals and staking router are the brand new tooling. Sometimes, we all have deadlines that seems impossible, but it's a deadline and it's unmovable. Our schedule is the same. We have a early testnet in the mid-March and mainnet launch somewhere in the early April. So timelines, as you can see on the picture, are quite tight. And going to the next slide. It's important to use the right tools to do the right job. So what we have here, we have two new tools. One is called KAPI and one is Ejector, and two pretty big updates, Oracle V2 and DSM, which stands for Deposit Security Module. First, let's talk about KAPI. KAPI is to serve, here is to serve information about keys, validators, and other data for tooling services like Ejector, Oracle V2, and DSM. KAPI periodically grabs the snapshot of the data from execution and consensus nodes and keeps this snapshot nearby. It's worth mentioning that KAPI consensus node connectivity is optional and can be disabled if it's not needed. KAPI in this case will serve only keys information. And getting all the state from Ethereum can take a while. And moreover, in case of using third-party services, it can cost a penny. KAPI helps us with that, since blockchain data is fetched by KAPI from Ethereum nodes. It's stored internally to be quickly served via REST API interface. And also KAPI is designed to support staking router and staking modules. And monitoring is crucial for KAPI. If it's not good if KAPI suddenly stops receiving new state from Ethereum, because obviously it will stop other services connected to it. Therefore, it's pretty crucial part of the whole system, and right monitoring is necessary. Good news, there are Grafana dashboards carefully handcrafted for you in GitHub repo, and you can take them, use them, and improve them if you like. And the next thing, the ejector. I think the great slide. Let's talk first how node operators should manage validator exits. A node operator should constantly monitor specific event called validator exit event emitted by the Oracle and respond to it. Respond by manually making voluntary exit call to consensus node, which is with a specially prepared exit message for the validator. It sounds pretty easy. However, this event can be triggered anytime, 24 hours a day, seven days a week. And the ejector is here to make the node operator's life easier. Node operator just loads a small batch of pre-signed exit messages into the ejector, and that's it. If the user wants to withdraw and the protocol buffer is empty, the protocol will emit event and it will be handled by the ejector. Super simple. There are some technical details here about the ejector. It will need execution and consensus nodes and a bunch of pre-signed exit messages. Pre-signed messages can be created with public and private keys of validators with tools like ETH2 and other tools. Public keys of the oldest validators can be obtained from KAPI. So to summarize, node operator should first prepare a batch of pre-signed messages, push this batch to the ejector, restart ejector, wait until pre-signed messages will be used by the ejector, and then just repeat everything from the beginning. Ejector can be loaded with pre-signed messages coming from various tools and support messages that are compatible with generic message format and ETH2 message format. Also, you can build your own automatization to keep ejector working. And the right monitoring is also important for ejector, because if node operators delays validator ejection, protocol will handle it and ask other node operator to eject one of its validators instead of delayed validator. Good news, Grafana dashboards are also included in GitHub repo, and you can use it. Here you can see our oracles. First of all, I want to say that the Oracle v2 update is important only for node operators that run current oracles. So if you don't run Oracle, you can skip this update. And let's speak more about oracles. Current Oracle reports only protocol TVL. V2 Oracle brings TVL, handles withdrawals and reports of exited stacked validators. Plus, New Oracle supports staking router and designed to be extensible. Actually, New Oracle is not just one. It's two different oracles, small exit bus oracle and big accounting oracle. They are bundled in separate applications and can be deployed separately. To handle withdrawals and new features of staking router, Oracle on-chain reports got a lot bigger. And bigger means more gas for each report and each Oracle instance, and that is not good. To spend less on reporting in that case and to be extensible, we used multiple techniques, and I'm going to tell you more about them. The first technique is hash consensus. The idea is simple. Oracles now agree on hash of the data instead of saving large data on chain. This is the first, actually, gas economy strategy. The second technique is a multi-phase reporting, and current Oracle just sends full report in one transaction, and the latest report costs even more, while V2 Oracle will send multiple transactions, splitting big last report into chunks. And of course, this multi-phase report will only be made after hash consensus to keep all the data on chain. And the third technique is what we call fast lane. Each oracle has its own number, so they have kind of ordering. And on each report, all oracles are split into two groups, fast lane group and group of remaining oracles. In a good weather, only fast lane group actually do their reports. The rest oracles does nothing, thus saving gas and transactions. Each report fast lane group is shifted to the right by one, so oracles are rotated and Oracle's order is checked on chain. This makes participation more predictable and equal. Let's talk about our small Oracle. Couple words here. Exit bus Oracle makes a decision what validator should be injected, and based on deterministic algorithm, emits the validator exit request transaction on chain. This event is immediately handled by the ejector, and he knows what to do with it. So that's it. Good news. Oracle v2 spent less gas on consensus. Bad news. They now require a Hive execution node which is bigger. Because correct calculation of protocol TVL after withdrawals error is only possible when looking at historic data, and only a Hive node can provide it. There are different execution clients with different capabilities and options regarding archive data pruning. Oracles will just need up to 7 days of historic data. Everything older can be safely removed. Nodes compatible with history pruning are Rigon, Besu, and Nethermind. So you don't need to store the whole history because it's quite huge. So summing up, previously every Oracle paid a lot, and the last one even more because of the report finalization. Now everyone pays less, and the participation is made more predictable and equal. A few words about deposit security model update. New version is designed to support staking router and can individually pose each staking model independently. That's actually all the updates for DSM. And that's all about the tools. As you can see, a lot of things changed, a lot of things left to be done and deployed, and schedule is tight. There will be readmes, manuals, Docker composes, and what to do's in testnet and in what order. Plus, there will be a team of DevOps rangers who can help with some technical issues. That's actually all from tooling team for today. Thanks for coming. Now, questions time.